Welcome to this tutorial on Kotlin Native. In this video, we'll explore how Kotlin Native allows you to compile Kotlin code into native binaries that can run on iOS, desktop platforms, and embedded systems. Kotlin Native is a technology for compiling Kotlin code to native binaries that run without a virtual machine. Unlike traditional Kotlin that runs on the Java virtual machine, Kotlin Native produces standalone executables that can run directly on the target platform's hardware. Kotlin Native uses LLVM, which stands for Low-Level Virtual Machine, as its compiler infrastructure. LLVM is a powerful toolchain that converts Kotlin code into machine code. The compiler then produces platform-specific executables that are optimized for each target operating system. Kotlin Native supports three main categories of platforms. First, iOS for building iPhone and iPad applications. Second, desktop platforms including macOS, Windows, and Linux. Third, embedded systems for Internet of Things devices and hardware systems. Writing Kotlin native code is identical to writing standard Kotlin. Here's a simple example. The fun keyword defines a function called main, which is the entry point of the program. Inside, we use println to output hello from Kotlin native. The syntax and structure remain the same as regular Kotlin. To configure your project for multiple platforms, you define targets in the Gradle build file. The Kotlin block contains platform-specific targets: macOS x64 for Mac computers, iOS ARM64 for iOS devices, Linux x64 for Linux systems, and Mingwa x64 for Windows using MinGW. Kotlin Native can produce three types of binary outputs. Executable creates a standalone application that can be run directly. Framework generates an iOS framework bundle that can be integrated into iOS projects. Library produces either static or dynamic libraries that other applications can link against. Kotlin Native offers several important advantages. There's no virtual machine overhead since code runs directly as machine code. It provides native iOS integration by generating proper iOS frameworks. You get C interoperability, allowing you to call C libraries directly from Kotlin. And finally, it produces binaries with a small footprint due to optimization. To create an executable binary, you configure the binaries block in your Gradle file. Inside, call the executable function. You can specify the entry point property to define which function serves as the starting point, typically set to main. Kotlin Native enables true cross-platform development. You can write your code once in Kotlin and compile it for iOS, desktop platforms, and embedded systems. This approach allows you to share business logic across different platforms while maintaining native performance and integration capabilities.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.